Okay, so today we're going to do a Foursquare review. That's what this is called. Okay, so let's look at this side of your Foursquare. All right, so if we have the equation x squared plus 10x equals negative 21. All right, just with it in this form right here, what would be the best place to start? Normally we would add 21 to both sides, right? But there's only one method that we wouldn't do that with. Can anybody tell me which one it is? Completing the square. Right? What's the first step in completing the square? But before we find C, don't we move C over to the other side? Well, we already did that on this one. So I'm going to start at completing the square. Okay? Everybody agree? Okay, so step one in completing the square is move C. C is already moved. What's my second step of completing the square? Find C. Right? Then we're going to add that space. Okay, what is that formula? How do we do that? C over 2 squared. Good job, guys. B over 2 squared. What is B in this equation? 10. So 10 divided by 2 equals 5, and then we're going to square it, which equals 25. Now I want to go ahead and put those blanks. X squared plus 10x plus blank equals negative 21 plus blank. What goes in my blanks? 25. What's my next step? Specifically, I heard it, factor. Good. What goes in here? X plus 5. Good job, guys. Equals just 4. Good job. Negative 21 plus 25 is 4. What's my next step? Take the square root of everything. When I take the square root of everything, I get x plus 5 equals plus or minus what? 2. Good job, guys. What's my final step? Set them both up. X plus 5 equals 2, or x plus 5 equals negative. Good job. So when I subtract 5 from both sides, on everything, I get x equals negative 3, or x equals negative 7. What did I just find? 2 roots, or the zeros of our quadratic equation, or the x-intercepts of our quadratic equation, correct? Okay. Which one do you guys want to do next?
Factor.
I want to do factoring too. Let's factor. Before we factor, what do I need to do with this? I need to bring the negative 21 over, because I know that I need this equation to look like a standard quadratic equation. So when I add 21 to both sides, I now have x squared plus 10x plus 21 equals 0. What do I do with this? Let's draw my box a little bit further down. We are going to factor it using a box. What goes in here? And what goes here? And since we don't know what goes here, we're going to use an X. Let me change the color for this. This is my A, B, and C. A times C is what? 21x squared. B is what? 10x. What two numbers, when I multiply, make 21x squared? How about 7x and 3x? When I multiply 7x times 3x, I get 21x. When I add them, I get 10. So let's put these in here. And let's factor. What goes here? X and X. X times what makes 7? Good. Let's check. 7 times 3, does that make 21? Yes. What do I do with these? Put them into parentheses and set them up to what? To equal 0. X plus 7 equals 0, or X plus 3 equals 0. When I solve it, what do I get? X equals -7 and X equals -3. Isn't that the same answer we got with the last one we did? Yeah. I've been trying to tell you guys that they all relate, right? And I'm going to show you how they all relate. We should get the same answer for every single one. The sad part is some of you will get that and then you won't do the work and you'll say, oh, I already know the answer. But that's not the point, right? The point is to be able to do each method independently, and since you have the answer to one of them, you should get the same answer each time, right? Okay. You want to do the graphing next?
Yeah.
All right, let's do the graphing. I think this one is the most challenging for you guys. But this is where we started. We had to start with graphing because that's why it all works out, right? That's what we're trying to find. We're trying to find the x-intercepts. Okay. Before we graph, take a look at this, guys. What is that? Does that sound familiar? It all relates, Michael. Fun. It all relates. Mathis, what is that? What is negative b over 2a? Who knows what negative b over 2a stands for? Armando? Formula for what? Almost. Not the axis of symmetry. So it's going to find the axis of symmetry on this graph. Hey guys, what's this part of the equation stand for? The discriminant. We learned that too. What's the discriminant find?
Where it's going to be.
No. What does specifically b squared minus 4ac, what does that tell us? No, not how we're going to get the root. What about the root? Not where they're at, how many there are. So you're telling me that this negative b over 2a tells me where it's going to act with symmetry is, and then this part of the equation is going to tell me how many I have. Whether I'm going to have one on this side and this side, or maybe they'll be up, there won't be any roots, right? Or whether it's going to hit and just skim right on the x-axis. What is that? What would the discriminant be if it was just going to skim the x-axis? One root. What do you get the discriminant if you only get one root? A 0. What do you get with the discriminant if you get 2 roots? Positive. What do you get from the discriminant if you get no root? A negative. Good. See how it's all coming together? Okay. I get very excited. I am so excited. If I didn't have heels on, I'd be jumping and leaping. Okay. Okay, guys. So let's start with negative b over 2a. X equals negative b over 2a. What's my b value? And what's my b value? I'm sorry, a value? 1. So this would equal negative 5. So negative 5 is my axis of symmetry. So if negative 5 is my axis of symmetry, what would be my next step? I know where the graph is going to be surrounded upon, right? It would be the axis of symmetry. Some of it's going to be to the right, some of it's going to be to the left. So what would be my first step? Not my roots. The y of what? What method? Okay, is it smiling or is it frowning? Why is it smiling? Coefficient is positive. Excellent. So this is going to be a smiling graph. What else about this graph? It's going to be over 5 and what? We don't know yet. How could we find out? Well, I guess we could do that. We could. We could, but we're going to do that with the quadratic formula anyway. What do I do next, guys? I have my axis of symmetry. What do I do? I don't just want to know roots. I already know my roots. If I wanted to cheat, what are my roots? We already found them. Hold on. Answer my other question first. What are my roots already? We already found them. Negative 3 and negative 7. Does that make sense? Negative 3 and negative... Here, we'll put them right here. They're right there. But that doesn't do me any good. I haven't drawn my graph. What do I need first? The vertex. What's the vertex of a graph? It's the bottom or the top of the parabola, right? How do I find it? I already have half of it right there. It's got to be on negative 5. It's either going to be negative 5 up or negative 5 down. How do we know? Good job. It must be, right? It must be down here because it's smiling, and I know that my roots are at negative 7 and negative 3. But if we didn't know all that and we didn't know the roots, pretend like we don't know the roots. No roots known. I just need to find my vertex. So what am I going to do to find my vertex? Plug in the number in what? What number am I going to plug in? No. Negative 5. I know that this is going to be my vertex right here, guys. Vertex. I already know that negative 5 has to be on the vertex. So don't I just plug in negative 5? Yeah. So remember we made a shell? Remember that way back when? Yes. It's going to be on the tab. I'm just going to smile. This is all review. Smile. Just need to smile. Okay. Negative 5 times negative 5 is what? No. 25. 10 times negative 5 plus 21. What do I get? No. 4. Negative 4. Good job, guys. So my vertex is going to be at negative 5, negative 4. Negative 5, 1, 2, 3, 4? Connor, writing. Everybody should be writing. Where do we get negative 4? Because 25, negative 5 squared is 25, right? Negative 50 has positive 21. 25 and negative 50 makes negative 25, right? And negative 25 and positive 21 make negative 4. Okay, now let's guess what's the next value we're going to plug in. No. Negative 7 or negative 3. Remember, we already know. Wink, wink, we already know what they are. So if I were guessing, why would you go all the way out here? We know it's probably going to be right around here, right? Because it's going to make this shape. So let's plug in negative 3. I wonder what's going to happen. If I plug in negative 3, I get positive 9 minus 30 plus 21 makes 0. Good. Negative 3, 0. We know that our graph must be symmetrical, so what would be the other 0? Negative 7. All right, you guys, we need 2 more values. You need 5 for full credit. It rhymes. 5 for full. Yes, you need 5 for it. It's catchy. Give me that. Is it catchy? 5 for full? Okay. What's another point we can put in? I would put in 0. You guys ready? I'm going to put in 0 because 0 is the easiest thing to put in. Even though I know that if I put in 0, it's going to shoot way up there, right? But let's just see what happens. So if we plug in 0, I'm going to get 21. Exactly. Because if 0's in here, then the only thing left is 21. I can't graph 21. I just know it's way up there. We'll make it red so we can see it. But I do know something else about it. If I know if I plug in 0, I get 21, I can also, by looking at my graph, tell what the other side would be. Can anybody get that? Here's my axis of symmetry. If I have to go over 5 this way to get to 21, I would also have to go over 5 this way. So my other value is negative 10 without doing any work.
Wow, great job.
Amazing. I like that. Amazing. And so, listen up, guys. So your graph just needs to point in that direction. And I'm not going to count you down because you don't have 5 points on your graph because obviously it's off the graph. But you do need to have 5 points in your table, showing the symmetric nature of the graph. Okay, we're almost done. What do we have left to do?
Quadratic formula.
Quadratic formula. All right, so I'm going to rewrite this one like we did the other one. You think it's the easiest one? I think completing the square is the easiest one.
Yeah.
This one's easy, but there's lots of steps where you can make mistakes. I think quadratic, or completing the square, has less steps, therefore you have less opportunities to make mistakes. And kind of, if you didn't create the square, then it's not going to work, right? Okay, so what's A?
1.
And what's B?
10.
And what's C? On the test, you, listen up, Patrick. On the test, I will not be giving you this formula. So let's do it again. A negative boy couldn't decide whether or not to go to
The club, the radical party.
a radical party or B squared and miss out on 4 amazing checks that was all over by 2 a.m. Okay? So, negative b plus or minus radical b squared minus 4 ac all over 2a. Plug these in. B is 10, so 10 goes here and here. A goes here and here, and C goes here. Equals negative 10 plus or minus 100 minus 84 all over 2 equals negative 10 plus or minus 16 or 4 squared all over 2. It's positive. The discriminant's positive means there are 2 roots, right? Follow this up here. Negative 10 plus what? 4 over 2 or negative 10 what? Minus 4 all over 2. What's this one? Negative 6 over 2, which is? Negative 6 over 2 is 3. Negative 3. And negative 14 over 2 is? And it's the same answer we've gotten all along. All right, you guys. Good job.